Hey guys, today we're going to talk about isosceles right triangles, or as I call them, 45, 45, 90 triangles. So it's called a 45, 45, 90 triangle because each of the angles are 45, 45, and 90. Now you might remember from last year that if we know that two of those are called base angles, if those are congruent, then we know that the sides opposite those two angles are also congruent. The converse of that is if these two angles, or if these two sides are the same, they're congruent, then the angles opposite them will be the same. So they would have to be 45 degrees since all my angles have to add up to 180. So you'll know it's a 45, 45, 90 triangle if it has two congruent sides, those are called the legs, and it has a right angle. Or if it has 45s in one of the angles. Okay, so these are called special right triangles. We have 45, 45, 90s, and next time we're going to look at 30, 60, 90s. These are special right triangles that are used a whole lot in trigonometry and things along those lines when you start to get into a little bit more of the upper level math. All right, so we are going to find the pattern because they must be special for some reason, right? 45, 45, 90 triangles have a special pattern. So first of all, we know that these two legs are the same, so I can put this as 3. And now let's use the Pythagorean theorem. The side across from my right angle is my hypotenuse, so x is c. So I have 3 squared plus 3 squared equals x squared. 3 squared is 9, plus 3 squared is 9. Add those together and we get 18 equals x squared. Then to get x by itself, we're going to have to take the square root of both sides. So we're going to take the square root of 18 and the square root of x squared. The square root of x squared, those cancel out, so we're just left with x. So now we're left with the square root of 18, right? Well, let's simplify the square root of 18. What's the biggest perfect square that goes into 18? 9. So 18 is 9 times 2. We can break that up into two separate square roots, the square root of 9, the square root of 2. The square root of 9 is 3, and then we're just left with square root 2. So the hypotenuse here is 3 square root 2. Now let's look at the next one. Since we know that both angles are 45, I know that these two sides have to be congruent. They have to be the same. So I know this bottom side is 4. So let's set up the Pythagorean theorem again. 4 squared plus 4 squared equals x squared. And I know x is going to be my hypotenuse because it's across from my right angle. 4 squared is 16 plus 4 squared is 16 equals x squared. 16 plus 16 is 32 equals x squared. To get rid of that squared, we're going to take the square root of both sides. So we have the square root of 32. The square root of x squared, that squared and square root cancel out, so we're left with x. So now we need to simplify the square root of 32. What's the biggest perfect square that goes into 32? 16. It's 16 times 2. So we can break those up into their own separate square roots. The square root of 16 is 4, and I'm just left with the square root of 2 after that. So we're left with 4 square root 2 for the hypotenuse. All right, so let's take a look at what we found so far. When both of my legs were 3, the hypotenuse was 3 square root 2. When both of my legs were 4, the hypotenuse was 4 square root 2. What do we think is going to happen when both of my legs are 5? Is that going to end up being 5 square root 2? Let's find out. So, since those two angles are congruent, we know that these two sides have to be congruent. They have to be the same. So we're going to do the Pythagorean theorem. 5 squared plus 5 squared equals x squared. And we know that x is our hypotenuse because it's across from the right angle. 5 squared is 25. Plus 5 squared is 25 equals x squared. And we know that 25 plus 25 is 50. To get rid of the squared on my x, I'm going to take the square root of both sides. I have the square root of 50. The squared and square root cancel out. So I'm just left with x. Now we need to simplify the square root of 50. What's the biggest perfect square that goes into 50? 25, right? That's 25 times 2. So we'll break those up into their own square roots. The square root of 25 is 5. And we're just left with the square root of 2. So, oh my goodness, it is what we expected it to be. Awesome. Here, let's pause. So let's go ahead and look at what we've noticed about these triangles. What do we know about the lengths of the legs? Remember, the legs are the ones that are not the hypotenuse. What do we know about the lengths of those legs? Those are always the same, right? They're congruent, or they're the same. And what you might have noticed about the length of the hypotenuse is that we went ahead and took my leg length and multiplied it by the square root of 2. So my hypotenuse is equal to my leg times the square root of 2. Now, a much easier way to think about this and why we actually have special right triangles and why they work is you might remember last unit we talked about similar triangles, right? We know that triangles are similar if all their angles are congruent, right? You remember that AA similarity, angle similarity. So every 45, 45, 90 triangle is similar to every other 45, 45, 90 triangle. And since they're similar, that means that their sides are proportional. But the cool thing about 45, 45, 90 triangles is that we know that proportion. If we have the leg over 1, that's going to be equal to the hypotenuse over the square root of 2. So we're going to use that ratio, and we're going to cross multiply and solve each time. Okay, so let's go ahead and solve for these missing sides. So first of all, we know that our leg goes over 1. So the length of the leg that we have here is 25. So I'm going to put that over 1. Remember that in a 45, 45, 90 triangle, the legs are going to be the same. So since one of my legs is 25, that means this leg also has to be 25. So that means that y equals 25. My hypotenuse is always across from my right angle, so x is my hypotenuse. He'll go over the square root of 2. So let's solve for x. We have 25 over 1 equals x over the square root of 2. And then we'll cross multiply. 1 times x is x. 25 times the square root of 2. Since those aren't the same kind of numbers, one is a regular people number, one is in a square root, we just put them right next to each other. 25 square root 2. So x equals 25 square root 2. Awesome. So what do we already know the value of in the next one? Do we already know x or y? We already know y, right? Because we know that our two legs are going to be the same length. So since that bottom piece is 10 square root 2, we know that y is also going to be 10 square root 2. So as I just mentioned, we know that our leg is 10 square root 2, and we know that our hypotenuse is always the side across from the right angle, so that's going to be x. So then we'll cross multiply to solve for x. We have 10 over the square root of 2, or 10 square root 2 over 1 equals x over the square root of 2. And then we'll cross multiply. 1 times x is x. Then we need to take 10 square root 2 times the square root of 2. So we know that the square root of 2 times the square root of 2 is the same thing as the square root of 4, or 2. So that means that x is equal to 20. Good deal. All right. Which value do we already know? Yeah, we already know y, because they're going to be, our two legs are going to be the same length. So we know that y is equal to the square root of 22. Oopsies. So like we just mentioned, square root of 22 is our leg. So we'll put that over 1. My hypotenuse is the side across from my right angle, so that's going to be x. Then we'll cross multiply. So we have the square root of 22 over 1 equals x over the square root of 2. Cross multiply. Move my face. Okay, so 1 times x is x. And then we also have to multiply the square root of 22 times the square root of 2. So we'll multiply them together underneath the same square root. 22 times 2 is 44. And now we need to simplify that. What perfect square goes into 44? 4, right? It's 4 times 11. So then we can break that up into separate square roots. The square root of 4 is 2, and then I just have the square root of 11 at the end. So x equals 4 square root 11. Go ahead and try that next one on your own. Okay, so we knew that our legs are going to be the same length, so x is going to be the square root of 27, and then we cross multiply to find y. So we have the square root of 27 over 1 equals y over the square root of 2. Then we cross multiply. 1 times y is y, and then we multiplied the square root of 27 and the square root of 2 underneath one square root to get the square root of 54. The biggest perfect square that goes into 54 is 9, so that's 9 times 6. The square root of 9 is 3, and we're left with the square root of 6, so y is equal to 3 square root 6. Okay, now these ones are a tiny bit different. This time, what do they give us the length of? A leg or a hypotenuse? Yeah, hypotenuse. So, what we're going to do here is, like we said, they gave us the hypotenuse because it's across from the right angle. So I'm going to put that 42 over my square root 2. And then it doesn't matter which one I use at first, x or y, because we know that those two are going to be the same length, right? So I'm just going to go ahead and put the x there. So we're going to have x over 1 equals 42 over the square root of 2. And then we'll cross multiply. 1 times 42 is 42. And the square root of 2 times x is just the square root of 2x. Now, if that were a 2x, we would divide by 2 on both sides, right? So we're going to treat it the exact same way even when we have the square root of 2. So we've got 42 over the square root of 2 equals x when we divide by the square root of 2 on both sides. Now we need to rationalize our denominator. So that means we need to multiply by the square root in our denominator. So we're going to multiply by the square root of 2 over the square root of 2. I'm going to bring this way. 42 times the square root of 2, since those aren't the same kind of numbers, we just put them right next to each other. We know that square root 2 times square root 2 gives me the square root of 4, which is the same thing as 2. Now, 42 and 2 are both normal people numbers. So we can take 42 divided by 2 and get 21. And then the square root 2 just comes along for the ride. So now we know x is equal to 21 square root 2. Now we know our two legs are congruent, so we know y has to be the same thing, 21 square root 2. Now, real quick side conversation. There's another way to look at this. We have 1 divided by x, right? I'm sorry, x divided by 1. If you think of 5 divided by 1, that's 5. 6 divided by 1, that's 6. X divided by 1 is x. And we still have that 42 over the square root of 2, right? Which is exactly where we ended up right here. So you can cross multiply and solve. If you're one of those, I want to do the same thing every time, cool. Cross multiply every time, you're going to be good. If you notice this situation where you can just take x divided by 1 and get x, and then you start rationalizing the denominator, please feel free. Okay, go ahead and try that next one on your own. All right, so on this one, we know that 72 is our hypotenuse since it's across from our right angle. And so we put that over the square root of 2. And then I chose x to use as my leg. So we could have gone 2 different ways. We could have said, okay, I have x over 1, so that's the same thing as x. And then let's just go straight to rationalizing our denominator by multiplying by the square root of 2 over the square root of 2. We end up with 72 square root 2 over 2. Take 72 divided by 2 because those are both normal people numbers and get 36 square root 2. Or we can cross multiply and get square root 2 times x equals 72. Then divide by the square root of 2 and go through the same rationalizing again and we'll get the same answer. Okay, so these next ones are going to come out a little bit gross. And I'm sorry, let me move my face first. Cool. Actually, let's move right here so that way if you need to see any of that. Okay, so still they're giving us the length of the hypotenuse since it's across from the right angle. And then I'm going to go ahead and just put in x for my leg. So we can either say, all right, so we have x over 1 equals 19 over the square root of 2. X over 1 is the same thing as x equals 19 over the square root of 2. Then let's rationalize our denominator. Let's multiply by the square root of 2 over the square root of 2. Then we end up with 19 square root 2 on top. And we know that the square root of 2 times the square root of 2 is the square root of 4, or 2. Now 19 isn't divisible by 2, right? So we're actually going to leave it just like that. X is going to equal 19 square root 2 over 2. Where did it go? There it is. Okay, thank God. And we know that our other leg is going to be the same length. Y equals 19 square root 2 over 2. Okay, go ahead and try the next one on your own. Okay, so our hypotenuse was 17 since that's the side across from the right angle. And I went ahead and used x as for my leg again. So we could cross multiply, but I just went ahead and said that x divided by 1 is x, and then we'll rationalize. So we'll multiply by the square root of 2 over the square root of 2, and we'll get 17 square root 2 over the square root of 2 times square root of 2 is the square root of 4, which is 2. And we know that our legs are going to be the same length, so y is also 17 square root 2 over 2. Okay, hope you guys have a great day. Bye.